Today we're talking about the amount of annuity. That's the value of the deposits at the end of an annuity. That's the formula, and this is it. So we looked at it a couple days ago, and we said A was equal to R, 1 plus I to the n, where R was basically talked about as the residual, which is basically the repeated deposit or withdrawal, where I and n were actually the same as everything we studied before. Now what we're going to do today is we're going to rearrange this formula to figure out the actual regular payment required for each given amount in the future. So if we can find the final value, if we know what that is immediately, we should be able to rearrange this and describe how to find the deposit. And we're going to call that R is equal to A bracket I divided by bracket 1 plus I to the n minus 1 bracket, where A is the amount of the investment, R is the amount of regular deposits made, and n is the number of deposits made, and I is the interest per compounding period. Now, we'll eventually do our first problem. Everything that we've done before is the same as compound interest, except for this R value, which is new. Our new problem is going to be called determine the regular payment required to save $10,000 in 8 years if payments are made monthly. Now, we start with our basic equation, and then we basically set up Aaron. So 10,000 is A. 8 years is going to be multiplied by times 12. Now, you'll notice that we didn't talk about the interest rate of this problem. So we're going to say the interest is about 5.1%. And we also said it was compounded monthly. So our R value is 0.051 and our I value is 0.051. And we're going to divide that by 12 because we're taking that interest and dividing by the number of times we compound in a year. Substituting into the equation, we're going to get the following, which is 1,000 bracket 0.051 divided by 12 bracket divided by bracket 0.051 divided by 12 raised to the 96, because 8 times 12 is 96 minus 1 bracket. Punching that into your calculator, you're going to get the following. We get R being $845.76 paid every single month. And now let's continue on to section number 2. For example number 2, it says determine the semi-annual payment required to accumulate $5,000 at the end of 5 years. So 5,000 is the end value. When we talk about semi-annual payment, this means we're looking for the R value. Okay? And because we're always paying, we call that the R value of the annuity. So we start with our equation and we start doing our computations. Now, just like I said before, 5,000 was our start value. Okay, so that's 5,000. That is our end value that we need to get, The R value we don't know, but the I is 0.039 divided by, well, because it's compounded semi-annually, we're going to divide by 2. Now, the number of years it's going to take to build up that is 5, and we're going to multiply that 5 by 2. Substituting, we get 5,000 bracket 0.039 divided by 2. And then we're going to divide by bracket 1 plus 0.039 divided by 2 raised to the, well, 5 times 2 is 10, I think. 10 minus 1. Now, doing our final computation, we're going to end up with R equaling about 457.68. Now, we're going to continue on with our problem. Let's make sure that every time we're doing these things, we're always making sure those numbers match. All right. A company needs $75,000 to replace equipment in 10 years from now. What quarterly payment is required to raise this money if the interest is 4.6%? The A value definitely has to be 75,000 because that's what we need to have at the end of the period we require. Now it says that it's being a quarterly payment, right? And there's other information as well. 4.6% as well. And the number of years. So if it's 4.6%, we're going to write 0.046, and we're going to divide that by, because it's quarterly, we divide that by 4. Because it's 10 years, we're going to change 10 years into quarters, so we're going to multiply that by 4. So that's 40. Now let's do our substitution. And now, when we do our computation, we're going to get R is equal to approximately 1,487.27. And that's how much you'd have to pay each quarter. For example 4. Everybody wants to be a millionaire. It says, if you start investing at age 17, what monthly payment would you need to make in order to be a millionaire by 65? Basically, we start with A. A has to be 1 million. So that's 1 with about 6 zeros behind it. We have our R. We don't know what it is. We do have our I, though. Our I is 6%. If you look up there, we're always looking for our percentage, but it's compounded monthly. So we got to eventually divide that by 12. Now, our N value, that's the hard part. You'll notice it says it goes from 17 to 65. So we actually have to find out how many years that is. So we take 65 minus 17, and we get about 48, I think. Okay, let me just check that on my calculator. Yeah. Yes, our answer is 48 years. So that's how many years it takes. So now we have to take our years and convert that into the number of months. So we're going to multiply that by 12. In doing so, we start with our equation since we're looking for R. And in that, we're going to write N is 576. Now, substituting, we're going to get the following. Punching that directly in your calculator, you're going to get a ridiculously low sum, being approximately $299.64 that you'd have to pay each month. That's a ridiculously low amount of money. So as long as you start doing this by the age of 17, you'll be able to pay about $300 a month, and you'll be able to save up that amount of money. So your homework is these questions that I've posted. I've prepared a worksheet online for you. Good luck.